Stress response. The body must respond to stress by mobilizing energy and body defenses to protect itself from stressors. So, the body has to use energy, and the body has to rely on its defenses to protect itself. Now, if it responds excessively, it can damage itself. If it doesn't respond enough, that means the stressor can get in and damage the body. So either way, the body can get damaged. So getting that perfect balance or near perfect imbalance is very important. There's a neurologic component and a hormonal component to stress, the stress response, but they're really quite intermingled. First, let's talk about the general adaptation syndrome. There's 3 stages: alarm stage, resistance stage, and exhaustion stage. It's the alarm reaction that we usually think of when we talk about a stress response. The central nervous system jumps into action. We've got norepinephrine and epinephrine and all these other hormones being released. We see an increased heart rate and oxygen intake. We see increased mental activity and contractility of the heart. This is, to a large part, the sympathetic branch of the autonomic system that's jumping into play. Then we move into a resistance stage, which is more long-term. Hopefully it's not too long-term, but it's there to stay. And that's when the body is trying to return everything to that balance, that homeostasis. From there, either the person can recover or they move to the exhaustion stage where they can no longer respond. The hormones are tired, the body is tired, whatever, but then we're looking at organ damage. Okay, the neurological components. There's lots of different pieces of the central nervous system that come into play. The first one is the brainstem. Remember, the brainstem is the basis of a lot of the plain old survival things. Well, this is where we start, and it is going to influence the responses of everything else. It's going to influence the autonomic nervous system. It's going to influence the cerebral cortex, the limbic system, and the hypothalamus. All of this goes through the central nervous system and the cerebral cortex to the hypothalamus. Then it branches out to the autonomic nervous system and the pituitary gland. The message of what to do is altered and specialized each step of the way. The cerebral cortex coordinates the cognitive aspects of the stress response, such as focus, planning, attention, and persistence. The limbic system coordinates the emotional aspects of the stress response, such as fear, anxiety, anger, and excitement, and it also stimulates the RAS, the reticular activating system. The thalamus coordinates sensory input related to the stressor, and then the hypothalamus coordinates the secretion of releasing hormones to initiate the endocrine response. It regulates the autonomic nervous system response, the balance of the sympathetic and parasympathetic systems. The reticular activating system increases a person's alertness and their muscle tension and contributes to the stimulation of the autonomic nervous system response. The endocrine components. Well, it has to do with the endocrine, the hormones from the hypothalamus, which is the corticotropin-releasing hormone. The sympathetic nervous system, which are the catecholamines, such as norepinephrine. The adrenal gland also releases a catecholamine, epinephrine, and it releases cortisol. So we have a stressor. It makes its way from the brainstem all the way to the hypothalamus. The hypothalamus then stimulates the sympathetic nervous system, which is part of the autonomic system. We have norepinephrine, increasing blood pressure, gastric secretions, pupil dilation, dilating airways, vasodilation to the skeletal muscles. Remember, this is the fight or flight that's going on. This is the response that's being stimulated in this stress situation. And then the epinephrine will increase insulin, glucose uptake by the skeletal muscles, increase heart contractions and output, and increase free fatty acids. So this is taking care of some of the energy needs. How are we getting the energy to support all of this increased metabolic activities? The hypothalamus is also stimulating the pituitary, and we have increased ADH and cortisol production. There's altered glucose, fat, and protein metabolism, again, to give us the energy we need for this situation. And it also suppresses inflammation and the immune responses. The other piece that was not on that previous chart pieces are the limbic system and the reticular activating system. The limbic system is coordinating the emotions that are happening in this stressful situation so we don't get out of control. And it also nudges the reticular activating system to be working, which will increase our alertness and muscle tension and feed into the sympathetic nervous system. Bottom line, the body and mind are primed to respond. It's a fight or flight. We are mentally sharp, we're physically revved up, and the metabolism is changed to have energy readily available to deal with the stressor. Now there's a downside. There's a suppression of the inflammatory and immune systems. And generally, that's sufficient. Those are things that require energy, and we're going to deal with it later once the stressor is gone. But if we are under excessive stress, it can cause an excessive inflammatory and immune response. Then we get increased humoral immunity, and we get an autoimmune disease.